Well, welcome to the Coding Serbia conference. I want to say first some gratitude to the organizers. This is my second time here, hopefully not the last one. I was here in 2013 and speaking about the hybrid application development. Today a little bit different story. I'm going to speak about the CQRS, or that subtitle is another view on application architecture. My name is Aleksandar Stoisavljevic. I work as a software architect at Levi company, and I don't want to spend a lot of time speaking about myself. So how about you? I want to get some info about you. So this is architectural talk, so who of you are architects or the tech team leads, the guys who decides on the architecture? Just share the hands, yeah, okay. Or in the smaller companies who has the chance to start the project from scratch, and yeah, okay, same old people. And who is using this entire architecture when starting the project? No one? Yeah, okay, good. I mean, this is good architecture. But what troubles me is that we are a lot of under pressure when starting the project, and meeting new people, changing the business domain model, and stuff like that. So I was start thinking about how we can improve, and yeah, we reached for that known architecture, and it was a long time that is used, established, and we know that it does not make any problems for us. So, but what actually, if we want to make our job more interesting, is that you have to move away from your comfort zone and start thinking differently. So real magic happens somewhere else. Start experimenting. So for today, I missed that part to explain what CQRS is. So CQRS is abbreviation for the Command Query Responsibility Segregation. So for agenda for today, I'm going to talk about a little bit theory about CQRS. Then I will present you two demos. One is using the Spring integration, implementation of the simple application with the CQRS pattern. And for the second demo, I will show you the same domain, but with another framework. So it's an Axon framework. And yeah, closing words. So let's start. CQRS in theory, and yeah, this funny subtitle, I don't mean cars. So how I end up with a CQRS. So I entered the CQRS term in the Google search, and I got this. So yeah, I wanted to use this as a funny joke. So I didn't mean cars. I wanted architecture. So, but cars made me think about how I'm going to organize this presentation. So as architects, we besides the stuff that we need to support from the ground up, that's availability, scalability, things that not only the feature set that you have to provide to your end customers. So that's one thing, but architects also has to think about other stuff. So I mentioned already availability, scalability, security, and I want to present the CQRS from the point of performance and response times. So cars nicely fits into my talks today. So humans can easily recognize when something is meant to be fast, right? So this is the Levi 9 official car that actually one of our founders are driving. So you can easily see the flat low tires, there's this spoiler, that's a big engine and stuff like that. Contrary on that, I mean on the other side, yeah, this is, you can easily recognize when something is not fast. And for locals, I mean from the guys from Serbia, you can recognize this is the Yugo. For the foreigners, yeah, this is something that was product of our automotive industry. Also, I wanted to share some info with you about what was the hardware about back in 70s. So you can recognize the old Apple, the old PC, and now we have something totally different, smartphones and Macs and stuff like that. So you can see that there is improvement in many areas. But what about the architecture? In 70s we use this model, entire architecture. And what about in 2015, 40 years later? We are still stuck with the same architecture. So I was thinking about how we can improve change from the performance perspective. Don't get me wrong, I mean, this entire architecture is working good. I've implemented myself for a few projects, so yeah, I don't object that. But in the matter of performance, what we are doing actually to gain more, more stuff that we can do with this architecture. So from the bottom up, we can introduce the query cache on the database level, query cache on the data access layer. If we are using some ORM tool like Hibernate, we can use second level cache of that tool. On the business logic, on the service layer, there is the stuff that you can cache your invocation of your methods. You can introduce more worker pools. Also, it's easily, this kind of architecture is easily horizontal scaled. You can add more nodes, like implement the same architecture. You just have to think about session replication. You can introduce the web cache, tags and stuff like that. But what we are actually doing with this architecture? We are making, monster. Okay, so what is CQRS? CQRS stands for the Command Query Responsibility Segregation. And the essence of this is that idea, or the notion, or whatever you want to call it, that you can have a different model for the changing application state than comparing to one that you want to read the info from your system. And this is, as always, there is some guy that made a definition of that term in the past, and this is a definition of Bertrand Meyer, and Bertrand Meyer is the French professor, and for older the guys who are in IT more than me, he's the founder of the creator of the Eiffel programming language. So I believe more in pictures than the long definitions. So what actually is CQRS is that from the client side, when you want to change the state of your system, you will issue commands. Commands will end up on the system. The gray arrow means that the command part also is responsible for notifying the query part that something has changed. And if you want to query the state, if you want to fetch the data, you do that differently on the different path. Okay, so a little about each of those. For commands, characteristics of commands, that commands actually are the messages to change the state. Messages should be handled by command handler. Commands usually, and not usually, when 100% does not return nothing. Does not return anything. Then each command actually describes the business intent, and each of the commands is immutable. From the query part, yeah, we want to fetch the data from the system. And characteristics of the query is that it reads states from the system or data store. Query does not change the state. And of course, if you want to fetch some results, then you should have the return value. Okay, another term that I want to tell you about is that event sourcing. It's not closely related to CQRS, and you will see why at the end. But usually talks of when you look for the resources on the internet, the CQRS, event sourcing, and domain-driven design are the three terms that are combined in one presentation. So in order for you to understand the demos, I will just speak about event sourcing and I will skip the part of the domain-driven design. So what is event sourcing? I will use this simple model. So I have this catalog. I have the products. Products can belong to different catalogs, and I have the inventory for each of the project. For the product. So if the product ID is the varchar, so let's say that. How I'm going to save the number of units in stock. So this is one of the ways. I have the primary key of the product ID. I have and on the third column I have the inventory, actually representing the state of how many units of that product is there. But actually, is it wise? And I object that's not wise because of one simple thing. I don't know how I get those 10. And that's the problem. If you're ever worked with a kind of bookkeeping application, then it's must have that you have how the units of the products changing through the time. So event sourcing is nothing. Event sourcing is nothing more than that. The change of the inventory of one product, I will store that as event. So the yellow ones, the highlighted ones, is the same product. So if I create the product, I claim the command that the product created event. That happened somewhere at 10 of September 2014. And yeah, for the product created event, yeah, I didn't have product on the inventory. Then I added 2. Then 3 lines later, I added 15. And yeah, same event, product added event, but this time with -7. And what that tells me that, about this product? Yeah, nothing much, except that I know what happened and when. And yeah, if thinking about this is kind of shop. So I created event, I added to my stock 2, I added then introduced 15 new one, and then I sell 7. So how I get the state if I change the model like this? So yeah, it's pretty easy. You will just need to do some aggregate function on the MySQL level or the SQL level, and you can get easily that the current amount of the products are 10. So I've used the sum group by inventory product ID. Okay, and that's it for the event sourcing. So in a definition, every change to the state of application is captured in event object. So I just showed you the events there. And these events objects are stored in the sequence as they were applied. So I can easily restore the state of my system. Okay, Spring integration. Yeah, we use a lot of Spring in our everyday job, so I use it a lot. So for this demo that I want to show you, I will just need to first explain what will happen on the high-level architecture. So we have the user that will express his intent creating something. In this creation, I will create a catalog for you for this demo. Then this will be transformed to command and put on the bus. This first bus is called the command bus. And then on the other hand of that command bus, there is command handler that will listen for the messages in the command bus. This command handler will pick this message, do stuff that is needed. In this case, I will store this new created catalog in the database, and then I will publish the message, and that message is actually event. And that event I will push to the event bus. On the query side, I've implemented the event listener. Event listener will pick up the event, do some magic there in the query, change the state, and then if I go on the different part of this high-level architecture diagram, so if I query after this, I will get the same information that passed through this path. Okay, time for demo. Let me just try to switch easily. I will show you later. So it's a Spring Boot application. It was easy to implement. I will just need to, just give me a sec. Okay. For event bus, I'm using the RabbitMQ. So Alvaro from the second talk on this conference. Thank you for that. Okay. And something happened. Okay. Let's try to see whether the RabbitMQ is up and running. Okay, it's up and running. I run it in Docker. Okay, now I will start the application. Let's just wait that the application is running. Okay, you can see here that the application has been started, and I will need. Okay, I will need prepared the JMeter script that will create 1,000 of catalogs for that. So just give me a second to light it up. Okay, and CQRS presentation, Spring workspace, JMeter. Okay, so I have the thread group that will create 1,000 of threads in 10 seconds. So let's hope for the best, and let's monitor if. Okay, so you see this yellow line. This means that the messages are published, and the red line is that the messages that are acknowledged, and there is some motion. Of course, you can see here that the logs now is overwhelmed. Also, we can monitor the results. And graph looks something like this. So if you take a close look to the numbers, I had an average of 82 milliseconds per request. So it's a command that will create a catalog. Just let's see how it works. So create catalog. Okay, so I missed that part again, sorry. What actually this JMeter do? It actually will use the UID generator to generate the catalog name, just to be sure that it's each time it's a different one. And let's make sure that every message is received and processed. So I have successfully stored 1,000 of catalogs. Okay, and for the, let's say, sake of demo, I just want to show you how the query part looks like. I will just ask for, let's say, this one. Okay, so the response is XML. I will just jump to that when I will be speaking about the application itself. So okay, so that's it about the Spring application demo. Now I will just guide you through the what happens or what is the infrastructure of the application. So you will notice that yeah, there is a lot of packages. That's one drawback of the CQRS. You will introduce the complexity to your system. But clearly, let me guide you just first before. So I have the API, catalog command API. I have the endpoint that will listen for the catalogs. It will listen for the HTTP method post. And you will notice that there is the method handle create catalog that can do validation of the input message or 202. One important thing about CQRS, when you're speaking about CQRS, you're speaking about asynchronous, to be asynchronous instead of being synchronous. So what actually happens is that your command part of the CQRS will just receive the message, and if from the validation perspective that message is okay, you will just say to client, okay, I acknowledged your message, and that's it. Everything else is doing behind the curtains. So 200 and 201 are not good examples of what CQRS is. So if I would send back to the client 201, that means that something is created. Well, actually, if I receive the message, it does not mean that mandatory it will be created. Something else can be broken in this pipeline. So yeah, actually but from the validation perspective of that received message, it's a 202. So I acknowledge your message. I will be dealing with this message. You can count on it. Okay. Let's see, command web controller. Okay. This was the interface. Now the real code. Actually handle create catalog. From the business validation perspective, I will just check if the catalog name is provided. If it's not, it's 400. And here is the interesting part. This is the catalog command gateway. I create the catalog based on the catalog name, and I'm using the catalog command gateway to create the catalog. And response, sending response back to the issuer that's saying, okay, I accepted your message. Actually, what happens behind the curtains is stuff in the Spring integration itself. So let me just share that information also with you. So I have the catalog command gateway. It will pass all the messages to the catalog command channel, and this catalog command channel actually for me represents the bus command bus. Also on the other side of that bus I have the service activator that will listen for the messages on catalog command channel, and let's see what is doing. So command service implementation. Sorry, not that one. It's a catalog command handler. Here it is. So I specifically stated there that just to make sure. So method that will service activator will call, it's a on message, and on message with the catalog created command, if it happens, it will try to save the catalog catalog. I created a catalog implementation and then saved using catalog service. And yeah, what I spoke a little bit earlier, as the success story to the saving, I will have to create event and publish that event. So I have, this service activator will output channel to catalog event channel. Catalog event channel is publish subscribe channel. So until so far we saw just the Spring integration. Now let's go through infrastructure. So what is good with Spring integration is that you can decouple your stuff from the, you saw that I used the command gateway. Here the first part is the Spring integration part, and the rest of below is stuff that how I'm going to make those event buses and stuff like that. So I use the RabbitMQ, I showed you that, and there is the RabbitQ. I'm using the fan out exchange. I have the outbound channel adapter, that's a catalog event channel, and this is closely related to one here, publish subscribe channel. So any of the systems that want to listen for events that my system produce just needs to write the event listener to connect to this event bus and listen for the messages. So this is good, and it's also important because if other system asks you to create a catalog, and I've created catalog, I received that command and said to that external system, okay, I acknowledged your request, I will do it. And the other system that called me just needs to implement listener on the event bus, and will just listen if I will publish the event that catalog is created. Okay, so speaking still of, I'm still in my application. I need to implement the query part, and this is the receiving event. I have, on the other hand, service activator that will, let's see, this create catalog event handler. It would be easy this way. Okay, so you saw the XML. Actually, I could use the same model, but I want to show you how the query part can be different. So in my system, I'm receiving the catalog name, but I'm producing the XML. So what is good about the CQRS? You can have a multiple representations of your data, and that's the part of the query. So if your, let's say, reporting department need a different kind of view of the data, you will just add new representation of your data. So data does not change. Data is truth in your system. So if they want, okay, let me now add, I don't want the XML. Okay, you will just add, I don't know, JSON or whatever. And actually, this is also speaking about the performance. You can easily just, let's see how the query part looks like. So I have the name of the catalog, that query that I show you, the URL. I queried the catalog by this name, but this is the response. Actually, I already prepared the response for the requester. So you can have additional ways of representing your data. This also the numbers are not bad, but it even can be even better if I added the cache at the query part. Because when so that cache will not go, currently the application goes to database to fetch the XML, but if you add the cache at the method invocation level on the service, you will prevent going to database, and the responses could be much more better. Of course, when you will invalidate the cache, you can invalidate on time manner, or you can invalidate on the receiving, actually firing up the event. So that's it for the Spring integration. We can go back if you want later on the question and answers. Okay, from perspective, when we started evaluating the CQRS, we also thought about, is there any framework that can help us a bit or help us at all? So we've encountered JDON and Axon framework. So Axon framework, this is the image. The guy behind the Axon framework is the Allard Buize. Sorry if I did pronounce that wrong. And if you take a look at this picture, it's a same picture, just rotated 90% in the clock counterwise. So if you rotate it like this, you will get the same picture there. So we still have the UI. Commands will end on the command handler. There is the domain. Domain will store the events in the event store. It will publish the events. There is the event handler here that will prepare the information database, and you have from the query part you have the thin data layer that will just present you the data from the query side. Okay, demo. Better. Again, it's a same model. Let me just start the application. Here I don't have the RabbitMQ. I will explain why is that. Okay. It's a Spring Boot application built with the Gradle. Started application. So now let's try a bit differently. Okay, and if I go to the catalogs, I do post. Okay, I need a header. That's the content type application JSON, and in the body provide catalog 80. Never mind. Okay, so you see that the response is 202. That's accepted. Here I just have this as a unique ID of the created catalog. Just let me see. It's a different database. CQRS Axon. I have the catalog, and yeah, you see that it's stored. How it works, or actually what is behind the endpoints are the same, so I won't spend time regarding that. I will just show you what is different in the Axon. And actually the changes are here in the infrastructure level. So Axon has components that you can wire in. For that I have to for the previous example I had to do that on my own. So you have the command bus, you have the event bus, you have the event source repository. Axon is a bit of different because it relies on domain-driven design, so you can't skip that part. And it has the event store. So here I used the simplest solutions, the file system event store. There is other event stores like JPA, JDBC, or whatever. Command bus also, this is the simplest one. It will do everything in one thread from the moment that it receives requests, create a message, put the message on the command bus, do the event handling, and publish the event. As I said, this is the implementation of the simple command bus. Axon provides others implementations of command bus like disruptor command bus, which basically has what I've done in the as example in Spring integration. So there is clearly distinguish when you distinguishing threads. When you're putting something on the bus, then there is thread executor that will pick that messages published. The command handler will pick those messages in separate thread, process it, create event will be published in the third thread and stuff like that. So that's why the performance is good. So yeah, I have 5 more minutes. Sorry, I will jump to the we can jump to the code, but eventually the Axon is about that. So, closing words. Are you doing CQRS? Maybe you do and you're not aware. In 2010, I had a project working on the dating site for the Holland, and we had a problem because a lot of people are using the reads and less of them are using the writes. So if I'm going to create the profile or change the profile, that kind of thing is rare. But a lot of people, when they create profile, they start searching. So when you have a lot of users, then you can imagine that you can have a lot of reads and you can have less writes. So we decided to split concerns, and we introduced something like a read-only data source. So we have the masters and slave. We were keeping writing our the changing of state of the application. We kept writing to the master database. We had the replication to the slave MySQLs. So paraphrasing a bit, but this is the model. And yeah, CQRS is just that. So if you're doing this, you're doing CQRS already. CQRS has nothing to do with the event sourcing and domain-driven design. It's just stuff that people usually think that comes together. So if you're doing this, you're already doing CQRS. Yeah, in a way of basic doing CQRS, but you're doing it. So why don't you try? So drawbacks. You saw that a lot of code, so you're adding complexity. Commands, events, yeah, they look almost similar, so you potentially have the code duplication. And yeah, you saw that when I stated that I want to save the catalog, it will take some time that it will propagate to the query part. So we are speaking about asynchronous systems that are eventually consistent. From the benefits side, CQRS are must-haves for the event source architectures. It has clear separation of concerns. So you don't mix your code in one class. That one service class is responsible for saving, for reading and stuff like that. So you clearly see that the part when I'm doing the changing the state, it's different than the querying. Support multiple denormalized views. I showed you that with the XML. I stored the catalog ID and catalog name. On the query side, I produced the XML. Times are fast, so now, yeah, you're ready to go to get out of your comfort zone and start doing CQRS. Presentation is here on the GitHub. The demo's also there. Other than that, you can find a lot of resources from Bertrand Meyer regarding CQRS, that Spring Framework, IOI, Axon Framework, and yeah, lately this guy Chris Richardson held a good talk on the San Francisco QCon, and he was presenting about using the CQRS in microservices. So, way to go. And that's it. Any more? No.